Welcome to Tomorrow Unveiled.
Where today we're not just peering into the future, we're kind of watching it stand up and, well, walk around.
Yeah, exactly. It feels like things are moving incredibly fast right now. Our dedicated research team pulled together a ton of data, and it really points to this inflection point in robotics. We're diving into what feels like the rise of the machines, but maybe less Hollywood and more factory floor. It's this convergence of really advanced AI and, actual physical hardware.
And it's happening now. We're seeing humanoid robots jump from sci-fi concepts, from prototypes into actual commercial products being industrialized.
Yeah.
It's pretty staggering.
So when our team looked at all this research, what was the big takeaway? What's the driving force here?
Well, the overwhelming consensus, the thing that just jumps out from all the data, is what we're calling the humanoid imperative. Pretty much every major player, they're laser focused on the humanoid form factor.
Okay, but why? That's the immediate question, right?
Yeah.
Why pour all this money, all this engineering talent into making robots that look like us? Why not stick with wheels or tracks or specialized arms?
It boils down to pragmatism, just
Wow.
pure, cold pragmatism. And that's what the analysts kept stressing.
How so?
Think about it. The world we live in, our factories, our warehouses, our homes, our cars, even the tools we use, it's all built around the human body. Door handles are at a certain height. Stairs have specific dimensions.
Right, keyboards, steering wheels, the distance between shelves.
Yeah.
It's all scaled for us. For 2 arms, 2 legs, opposable thumbs.
Precisely. So if your goal is a general-purpose robot one that can eventually do lots of different things in lots of different environments without us having to completely rebuild everything,
And you build it like the existing general-purpose machine, a human.
you got it. It avoids needing trillions in infrastructure spending. It's just the most practical, arguably the quickest route to getting general-purpose embodied AI out there and working at scale. It's the path of least resistance.
Okay, so the humanoid shape makes sense. But actually building these things and making them smart enough, that's where it gets really complex. Our research team identified this sort of central conflict happening right now. They called it a technological two-front war.
Yeah, that's a really good way to put it. It's happening simultaneously on two fronts that are totally linked.
Front number one.
Front number one is the shell. That's the hardware race. Can we actually industrialize this? Can we mass produce these complex mechanical bodies, make them durable, power efficient, and crucially, drive down the cost?
And front number two.
That's the ghost, the intelligence, creating the AI brain that lives inside the shell. And not just any AI. It needs to be robust, adaptable, truly generalist. It can't just be repeating pre-programmed moves. It has to perceive, reason, and act in the messy, unpredictable real world.
So the goal for you listening to Tomorrow Unveiled today is to really unpack this. We'll synthesize the big hardware news, we'll dissect these new AI architectures, the ghosts, and look at the, frankly, surprising economic bets being placed that show this isn't some far-off dream, it's happening right now.
And we'll definitely spend some time later digging into the really thorny challenges too. Safety, geopolitics, the stuff that still needs figuring out.
All right, let's kick off with this fundamental shift in thinking. Our research team flagged this term, physical AI, or embodied AI. It's different from the AI we usually talk about, right? Like LLMs.
Totally different. Physical AI or embodied AI is really the convergence points where AI stops just being about processing data digitally. You ask ChatGPT a question, gives you text back.
Right.
This is about AI systems that perceive the world through sensors, reason about it, and then critically act in the physical world using a body. They use that body as their interface. It's the difference between writing an email and tightening a bolt.
And that leads to this really important distinction, the one that explains all the investment we're seeing. The move from automation to autonomy.
Exactly. Traditional automation, think factory robots in cages, it's rigid. It does one task over and over perfectly, but only if everything is exactly where it expects it to be. It's pre-programmed.
Doesn't handle surprises well.
Not at all. Autonomy, on the other hand, is about being self-learning, adaptable. It uses real-time feedback. If something's out of place, it adjusts. That's the game changer.
So the whole focus has shifted. It's not, can we build one cool prototype anymore?
No. The question now, the industrial question is, can we build millions of these things? Reliably, cheaply? That's the industrialization front. Mass producing the hardware shell.
And who's really pushing the envelope on that cost front? The name that kept coming up in the research was Tesla.
Yeah, Tesla's making a huge strategic bet here with Optimus. Our team highlighted this. They're positioning this humanoid robot not as some side project, but potentially as their biggest product ever. Bigger than cars.
Bigger than cars. Wow, okay.
That's the signal. This is core to their future. And the absolute key to that strategy, the number that's shaking things up, is their target cost of goods sold CUGS.
What are they aiming for?
They're targeting $20,000 CUGS for Optimus once they reach mass production scale.
Wait, $20,000 for a whole humanoid robot? That sounds kind of nuts. Current ones cost what? Hundreds of thousands? Millions sometimes.
Oh yeah, easily. But the analysts tracking Tesla think it is achievable for them, but only because of their extreme vertical integration, leveraging everything they learned from scaling car production, their mastery of manufacturing.
Okay, but let's just focus on the impact of that $20,000 number. What does that do?
It's designed to be fundamentally disruptive, profoundly disinflationary. It's a direct challenge to the cost of human labor across the globe.
How does the math work out?
Well, think about it. A $20,000 asset, depreciated over, say, 5 years, add in costs for electricity, maintenance. If that robot can run 247 or even close to it.
The hourly operating cost plummets.
Exactly. You're potentially looking at under $3 an hour, maybe even less when you amortize it fully.
Which is way below minimum wage in the U.S., let alone average manufacturing wages, which can be $25, $30 an hour or more.
Precisely. So for a big factory in the logistics hub,
Yeah.
suddenly the economics just flip. The ROI becomes undeniable almost overnight. It's a direct shot at competitors who are still venture-funded and dealing with six-figure unit costs. Tesla's basically saying, we're going to win on cost, assuming the capability is good enough.
And how are they planning to hit that $20 K number? You mentioned vertical integration.
Yeah, they control everything. The batteries, the drive units, the custom actuators that move the joints, the AI chips.
The whole stack.
The whole stack. And crucially, they're designing and building a Gen 3 automated production line whose job is to build the robots.
Yeah.
The product isn't just Optimus. The real scalable product is the factory that builds Optimus. That's the mindset.
But it's not just Tesla in this hardware race, is it? We saw something pretty stunning from XPeng, the Chinese EV maker, this week.
Oh yeah, the XPeng Iron Robot reveal was jaw-dropping. It was almost a counterpoint to Tesla's focus on pure utility. XPeng went for extreme human likeness, fluidity.
What were the specs on that?
Pretty intense. 178 centimeters tall, 70 kilos, and get this, 82 degrees of freedom, or dove.
82. That's a lot of moving parts.
It's huge, especially when you consider they dedicated 22 dove per hand. That signals a massive focus on trying to achieve human-level dexterity, fine motor control.
But it wasn't just the specs, right? It was the demo itself.
The demo was uncanny. The robot walked with this incredibly smooth, natural-looking gait. They mentioned a flexible spine, like a human's, bionic muscles, even flexible skin covering it. It was so fluid.
People didn't believe it?
Exactly. It dove straight into the uncanny valley. People online were convinced it was just a person in a very convincing robot suit.
So what did they do?
This was amazing. The CEO, Xiaopeng, he actually went on stage and dramatically unzipped the robot's outer skin right there, live, to show the hydraulics, the metal skeleton underneath. Just to prove, look, it's real.
Wow. Having to prove your robot isn't a human in disguise? That says something about how far the hardware's come, visually at least.
Definitely. And technically it's packed. 3 custom AI chips from XPeng, delivering 2,250 TOPS. That's trillions of operations per second of compute power on board.
Serious brains.
And they specifically mentioned using the world's first all-solid-state battery in a humanoid. They cited safety and higher energy density crucial if these things are working near people for hours on end.
And XPeng's ambitions for scale, are they just as aggressive?
Just as aggressive. They're targeting mass production of these advanced humanoids by the end of 2026. So yeah, this isn't just R&D, it's a full-on commercial race, a global one.
Okay, so we have Tesla pushing the cost down, XPeng pushing the human-like movement, but there's another angle, right? The democratizer.
Right, we got to talk about 1X Technologies. They're backed by OpenAI, which is interesting in itself. Their focus seems less on factories and more on, well, us, consumers, homes.
They actually launched pre-orders, didn't they, for their NEO robot?
They did. It's one of the first times you, as an individual, could actually put money down on a humanoid robot helper. Delivery is expected in 2026.
And the price, is it hitting that magic number?
They're targeting that same $20,000 price point for outright purchase. But interestingly, they're also offering a subscription, $499 a month.
Okay, that makes it feel more like a service, less like buying a car. More accessible, maybe?
That seems to be the idea. Make it consumable. And NEO is explicitly designed for home use. Big emphasis on safety soft body materials, a special tendon drive system they patented, meant to mimic muscles for gentler, quieter movement.
What can it actually do right now?
The initial stuff is pretty basic. Opening doors, fetching things, turning lights on or off. But the promise is that it learns. Its capabilities will grow over time through software updates. Kind of like your phone gets new features.
So Tesla driving cost, XPeng driving fluidity, 1X driving accessibility. The hardware shell is clearly evolving incredibly fast.
Yeah, the race to build millions of capable, affordable shells is well and truly on. But like we said, the shell's only half the equation. Can these things actually do useful stuff in the real world? That brings us to validation. Yeah, the focus has really shifted. Our research team noted this clearly. It's not enough to just show off cool demos anymore, like robots doing parkour.
Right, the viral videos were fun, but
now it's the show me the ROI phase. The industry is focused on validating these machines through difficult real-world tasks, mostly industrial tasks, for now.
that makes sense. Take Boston Dynamics Atlas. We all saw the backflips. What's it doing now?
The focus is totally different. They recently showed footage of the new all-electric Atlas. They ditched the hydraulics, working in a simulated factory. It was autonomously picking up automotive parts, moving them around.
And it looked different, didn't it? The movement.
Yeah, uncanny is the word. Because it's electric, the joints can rotate in ways humans can't. The torso can twist like 180 degrees almost instantly to grab something behind it. It's efficient, but definitely not human-like in that moment.
But it was doing it autonomously.
That's the key. Using vision models to locate the parts, figuring out how to grab them, reacting if something shifted. It wasn't just following a simple pre-programmed path. It showed adaptability.
Okay, simulated factory is one thing. What about real factories? Any boots on the ground yet?
Oh yeah. The biggest example, the one getting a lot of attention, is the Figure AI partnership with BMW. Their Figure 02 humanoid is actually working shifts at the BMW plant in Spartanburg, South Carolina.
Doing what specifically?
It's doing sheet metal placement, up to 1,000 placements per day, the reports say. And this isn't some simple pick-and-place task.
Why is it so hard?
According to Figure's CEO, it involves inserting sheet metal parts into a very narrow pinpole fixture less than a centimeter wide. It requires incredible precision.
Millimeter level.
Millimeter level accuracy, plus the right amount of force control. You can't just jam it in. You'll bend the part or break the fixture. You need that tactile sense. He called it 10x harder than any stationary tabletop manipulation task.
And the Figure 02 is nailing it.
Apparently so. They've shown it reducing the cycle time for that operation, making it faster than previous automation attempts. That's a huge proof point, showing that level of precision and reliability in a tough industrial setting.
That really does bridge the gap between demo and deployment.
Absolutely. And Tesla's not sitting still either. They're showing improvements in dexterity, which is maybe the hardest part. They demoed Optimus with a new hand, 22 degrees of freedom, same as X-Peng's.
What was the demo?
Catching balls thrown at it. Which sounds simple, but it shows improved hand-eye coordination, reaction time. They also highlighted a soft protective layer on the fingers, important for preserving sensors while handling objects.
So BMW, Tesla. You mentioned other car companies are involved too.
Yeah, the research confirms Mercedes-Benz is trialing Apptronic's Apollo robot. And Hyundai, which owns Boston Dynamics, is deploying Atlas in their own facilities. It's becoming industry standard to at least be piloting these things.
It really feels like deployment is happening now, not years away.
It is. And part of making deployment work is figuring out how to train these robots efficiently. Which brings us to something cool from RealMan Robotics.
What did they show?
They demonstrated cross-regional teleoperation, basically remote control over a huge distance.
How far?
They linked Beijing to Hangzhou at the IRS conference that's 1,200 kilometers apart. A human operator in Beijing was controlling their RealBI humanoid in Hangzhou in real time.
Doing complex stuff.
Yeah, interacting with people at the conference booth, handing someone a piece of fruit, passing a towel. It proved their system has low enough latency and robust enough perception to handle interactive tasks over that kind of distance.
That's technically impressive, but what's the strategic angle?
Data collection. Massive data collection. That Beijing-Hangzhou link isn't just a demo, it's their engine for training AI. Our research team noted they're using this setup to collect over 1 million high-quality multimodal data samples.
Video, force feedback, joint positions, all from real interactions.
Exactly. Which is crucial for training the AI brains. the ghosts, effectively.
Hmm.
It feeds into this hybrid learning approach that seems pretty standard now.
The human in the loop idea.
Right. You see it with 1X's NEO, Aptronus Apollo. If the robot encounters something it doesn't know how to do, a human operator can take over remotely, guide it through the task.
So the job gets done, and the robot learns by watching the human.
Precisely. It learns via imitation learning while still being productive. It's a smart way to bootstrap the AI's capabilities.
And this is even reaching really high-stakes industries now. I saw a mention of the nuclear sector.
Yeah, that was Capgemini and Orano deploying a humanoid called Hoxo. First one in the nuclear industry, apparently.
Wow. The safety requirements there must be off the charts.
Absolutely. Using it for things like replicating human movements, for safety checks, precision tasks. It's huge validation. If these robots are trusted in a nuclear facility, using digital twins and AI for autonomous operation in hazardous areas, that says a lot about their perceived reliability.
Okay, so the hardware shell is getting real work done. The training methods are maturing. It feels like the missing piece, the truly revolutionary part, has to be the AI inside the ghost.
Exactly. And that's where we're seeing a fundamental shift away from old approaches.
Yeah.
It's all about new AI architectures now.
Okay, let's unpack this AI revolution. Our research team kept emphasizing this move away from, what do they call them? Monolithic models.
Yeah, monolithic AI models. The idea used to be to build one giant neural network, a single do-it-all brain that would try to handle everything from seeing the world to controlling the finest motor movements.
And that didn't work so well.
It was brittle, hard to train, hard to adapt, hard to understand when it failed. The whole field, based on the research we reviewed, is shifting towards hybrid, modular, hierarchical architectures. Think less, one giant brain, more.
Yeah.
Like a cognitive system with specialized parts.
Like our own brains, maybe. Different areas doing different things.
Sort of, yeah. It's moving towards a proper operating system stack for robots. Instead of one black box trying to map camera pixels directly to motor torques, they're breaking it down. You've got layers. Yeah. A high-level strategist, a locomotion controller like a cerebellum, and low-level motor controllers like a spinal cord.
All right, let's start at the top. The orchestrator, the strategist.
Yeah.
This is the big picture planner.
Exactly. This is typically a high-level vision language model, or VLM. It understands complex instructions like clean the kitchen and figures out the steps involved.
How does it differ from just asking, say, ChatGPT to make a plan?
Well, one really exciting concept highlighted in recent academic work is called Maestro. Here, the VLM, they use Gemini 1.5 in the study, acts like a coding agent.
A coding agent. It writes code.
Dynamically, on the fly.
Mm-hmm.
Its job isn't to do the cleaning, but to write and execute Python code that calls upon a predefined toolkit of simpler, reliable robot skills.
Whoa, okay, so if I say clean the kitchen, the Maestro VLM thinks, okay, step 1, find sponge. Step 2, wet sponge. And it actually writes Python like call find sponge, then call wet sponge?
Pretty much, yeah. It breaks the complex task down into a sequence of calls to these known reliable skills in its toolkit, like open drawer, pick up sponge, Movito sink, turn on faucet.
And it's actually genius. It's like a project manager delegating tasks to skilled workers.
Exactly. And the really powerful part is the feedback loop. What happens if open drawer fails because the drawer is jammed?
The robot just stands there.
Not with Maestro.
Yeah.
The VLM gets the failure feedback, maybe sees from the camera that the drawer only opened halfway. It analyzes why it failed, and then rewrites the code. Maybe it tries nudge drawer with shoulder first, then calls open drawer again. It replans in real time.
Okay, that's seriously cool. But how do you stop it from writing dangerous code, like punch wall?
That's the beauty of the modular toolkit approach. The VLM doesn't have unlimited freedom. It can only call the functions that are already in its pre-approved, pre-verified toolkit. And those toolkit functions like walk forward 1 meter or grasp object force of 5n are designed and tested to be physically safe and robust.
So it's creativity, but within safe boundaries.
Exactly. Constrained creativity. And what's really telling is that this approach, this Maestro system, dramatically outperformed the big monolithic end-to-end models when it came to zero-shot generalization, doing new tasks it hadn't explicitly been trained on.
Because it could just recombine its existing tools in new ways using code.
Right. And the policy, the robot's plan, is literally human-readable Python code. You can see what it's trying to do. Plus, extending the robot skills is easier.
Yeah.
You just add a new safe tool to the toolkit for the VLM to use.
Okay, so the strategist writes the plan, but it needs something to actually execute the complex physical movements, right? The walking, balancing.
Yep. That brings us down a level to the locomotion controller. Think of it like the robot's cerebellum handling muscle memory and coordination.
And the key concept here was BFM-Zero, Behavioral Foundation Model.
Right. BFM-Zero is fascinating. It's a foundation model, like the ones used for language, but trained purely on behavior, physical movement.
How do they train it?
Imagine feeding it just tons and tons of motion data. Could be from simulations, from real robots, maybe even motion capture of humans or animals. Walking, running, jumping, balancing, falling gracefully, getting back up. It learns this huge repertoire of whole body motions, mostly through unsupervised reinforcement learning. It builds a kind of unified map of possible physical skills.
So it just knows how to move in a general sense.
Pretty much. The amazing part is the high-level strategist, the Maestro VLM, doesn't need to worry about the complex details of walking on gravel versus carpet. It just needs to prompt the BFM-Zero cerebellum with a high-level command.
Like literally typing, walk forward carefully.
Essentially, yes. Or go to T-pose, or navigate to coordinates XY. And the BFM-Zero model takes that prompt and executes the robust, optimized, context-aware skill using the robot's body. They've already shown this working on real hardware, like the Unitree G1 humanoid.
That's huge. It takes the incredibly complex problem of dynamic bipedal locomotion and sort of abstracts it away for the planner.
It democratizes sophisticated movement. You don't need teams of engineers hand-coding control loops for every possible situation. The foundation model handles the how of moving.
And this modular thinking, this split between planning and skilled execution is showing up elsewhere, too.
Definitely. We saw research combining classic physics-based planning, like deciding where to place the next footstep based on the terrain, with a learning-based controller that figures out how to execute that step smoothly and robustly. This blend of old-school engineering reliability and new-school AI flexibility seems really powerful, especially for handling unexpected pushes or uneven ground. It's refining that spinal cord layer.
So the AI architecture is becoming much more sophisticated. Are the big tech companies providing the infrastructure to make this usable at scale?
Yeah, absolutely. Look at Nvidia. They're a huge enabler here. They announced GR00T N1, which is an open, customizable foundation model specifically for humanoids.
What's special about their architecture?
They explicitly use a dual system approach inspired by how psychologists think we think. They have a fast System 1 for reflexes, immediate reactions, keeping balance.
Like pulling your hand from a hot stove before you even consciously register the pain.
Exactly. And then they have a slower, more deliberative System 2,
Yeah.
which is the VLM doing the complex reasoning, planning multi-step tasks, understanding language.
That makes sense. Robotics needs both. You need to plan, but you also need to react instantly if you start to fall. How do they manage the speed difference?
System 2, the planner, operates at a lower frequency, maybe 7-10 times a second. It takes in the scene, thinks, makes a plan. System 1, the reflex controller, runs much faster, 50, maybe 200 times a second, translating those plans into smooth joint movements and making constant micro-adjustments for balance. If the robot stumbles, System 1 catches it instantly, way before System 2 has even finished processing the stumble.
It solves that trade-off between needing deep thought and needing instantaneous physical control.
Precisely. And then you look at someone like XPeng. They're vertically integrated on hardware, right?
Right, custom chips and everything.
Well, they're doing the same on the AI side.
Right.
They detailed their own stacked VLT, they call it, Vision Language Task Model. It integrates conversation, walking, interaction, all running natively on their custom Turing AI chips. They're aiming for that seamless, low-latency connection between the ghost and the shell by controlling the entire pipeline.
So the takeaway here is the Ghost isn't just one thing anymore. It's becoming this layered, modular, sophisticated operating system.
Yeah, an OS ready to be installed into these increasingly capable, mass-producible shells. And that technological maturity, that readiness on both fronts, that's why we're suddenly seeing serious money flow into real-world deployment.
Which brings us neatly to the economics, the tipping point. Okay, let's talk money. Because our research team kept circling back to that $20,000 OGS target as the absolute game changer, the industrial tipping point.
It really is, because it shifts the whole conversation about robots versus human labor. It stops being primarily a technical question, can the robot do the job, and becomes almost purely an economic one.
If the robot can do the job reliably,
then the ROI calculation becomes brutally simple and often undeniable. Especially if that machine can operate 24/7, doesn't need breaks, doesn't need benefits, doesn't call in sick.
We touched on the hourly cost earlier. Let's break that down again. A $20K robot, high uptime in a factory. What's the real cost?
Even being conservative, factoring in energy, maintenance, the initial purchase price spread over a few years, you're easily looking at an effective operational cost under $5 an hour for a manufacturer buying in bulk. Some analysts are projecting these humanoids will hit the market with a cost capability equivalent of under 10 hours initially, but on a clear path to under $1 per hour before 2035.
Under $1 an hour.
Yeah. Now compare that to human wages in manufacturing hubs, US, Germany, even parts of China where $20, $30, $40 an hour, including benefits, is common. The payback period on the robot investment could shrink to just months.
That kind of economic pressure explains why we're seeing these huge commercial commitments suddenly. We're moving past just pilots.
Way past pilots in some cases. The standout example our team flagged was the deal between Agility Robotics and Schaeffler AG.
Schaeffler. They're a big global auto and industrial supplier.
Massive. And they've committed to purchasing and deploying Agility's digit humanoid robots across 100 of their global manufacturing plants by 2030.
100 plants.
That's
not a trial balloon. That's a strategic deployment.
Absolutely. Analysts estimate that even the initial phases represent a commitment, likely in the hundreds of millions of dollars. But more than the money, it signals that a major global player is fundamentally restructuring its future manufacturing strategy around humanoid automation. They're planning to automate tedious, repetitive tasks across their entire footprint.
And it's not just Schaeffler. We mentioned the auto industry pilots earlier.
Right. BMW with Figure, Mercedes with Apptronic's Apollo, Hyundai Boston Dynamics with Atlas. Every major car maker is actively integrating these robots onto their lines now. It's a consensus bet on the next wave of productivity.
Now, the narrative around this is often about replacing jobs, but the research suggests the initial driver is something else.
Yeah, the consensus view, at least for the near term, is that these deployments are primarily targeting huge existing labor shortages.
Filling gaps rather than displacing workers immediately.
It's exactly. Focusing on the dull, dirty, dangerous jobs that companies already struggle to fill. Or roles where demographics mean there just aren't enough workers available. The U.S., for example, was cited as having something like 622,000 unfilled manufacturing jobs right now that are potentially suitable for humanoids.
So phase one is augmentation, filling critical needs in manufacturing, logistics, maybe elder care where shortages are acute.
That seems to be the strategy.
Yeah.
But the applications are definitely broadening beyond the factory floor. We're seeing pushes into the service sector too, although they're starting cautiously.
We talked about 1X targeting the home. That's the ultimate consumer play.
Right, but look at XPeng's rollout plan. It's quite pragmatic. Their founder actually admitted something interesting. When they tried using their advanced robots for tasks like tightening screws repeatedly on an assembly line.
Yeah.
The high forces and repetition wore out the complex 22 direct hands within a month. Replacing those hands constantly made it more expensive than human labor for that specific task right now.
So the dexterity and durability aren't quite there yet for all industrial tasks.
Not for everything, especially high-force, high-cycle tasks and the home environment. It's just too chaotic, too unpredictable for current AI to navigate safely and reliably all the time.
So where is XPeng deploying first, if not factories or homes?
Controlled commercial settings. Big corporate showrooms, high-end retail stores, maybe mall information desks. The robots act as greeters, guides, information providers.
Lower stakes, less physical demand, more predictable environment.
Exactly. It avoids the factory durability issues and the home chaos issues while still letting them showcase the technology, gather interaction data, and prove value in customer-facing roles. It's a smart, phased approach.
It shows that even with all the excitement and the $20 K target, companies are being realistic about finding the right initial markets where the tech delivers ROI today.
But this rush to deploy, even pragmatically, throws a spotlight on the major challenges that still haven't been fully solved. Dexterity, safety, and the whole geopolitical picture.
And hey, speaking of interaction, we love hearing your thoughts. If you're watching on YouTube or listening on your favorite podcast app, drop a comment. Let us know what you think about humanoid robots turning up in our workplaces, maybe eventually our homes. Does it excite you, worry you? Let us know. And while we dig into these critical challenges, maybe take a second to subscribe to Tomorrow Unveiled. It really helps. Okay, let's shift gears to the hurdles. The big problem's still on the table. Our research team was clear. Despite huge strides in walking and planning, that human-level dexterity, the fine motor control, that's still a massive roadblock for everyone.
Yeah, that's a strong consensus point from robotics experts. It's not just about building hands with enough joints. It's about the sensing and the control.
That's missing.
Force and haptic feedback, mostly. The analysts argue that current training methods, learning from videos, simple teleoperation where the operator just controls position, they don't give the robot that sense of touch, of pressure.
So the robot can see where the screw needs to go, but it can't feel if the threads are engaging correctly or how tightly it's turning it.
Exactly. It lacks that intuitive physical understanding that we rely on for almost any manipulation task, from turning a key to picking up an egg without crushing it. This is why really complex tasks like delicate assembly or, robot surgery are still largely out of reach for these general-purpose humanoids.
And XPeng's experience with their hands wearing out in the factory, that's a direct consequence of this limitation. Trying to do precise, forceful tasks without good tactile feedback.
Seems likely, yeah. It points to the need for better sensors, better control algorithms that incorporate force, maybe even new learning techniques that go beyond just visual imitation. True tactile intelligence is the next frontier.
Just as critical, maybe even more so as these robots leave the cage, is safety. And the rules haven't caught up, have they?
Not even close. Our team highlighted the urgency being voiced by groups like the IE, who are scrambling to develop standards. Think about it. A traditional industrial robot arm is bolted down, usually behind a fence. A humanoid robot is walking around warehouses, potentially retail stores, maybe even schools or homes eventually. The risk profile is completely different.
What are the big risks the IE report flagged?
They broke it down into several key areas. First, just physical safety. These are big, heavy, powerful machines moving potentially quite fast. What happens when one falls? Or collides with a person or unexpected obstacle?
That's the obvious one. What else?
Second, psychosocial impacts. Because they look human, we might trust them inappropriately. Or people could form unhealthy emotional attachments. Or conversely, a sudden violent failure could be genuinely traumatic for people nearby. Third, privacy. These things are rolling sensor platforms, cameras, microphones everywhere. In your workplace, maybe your home. The surveillance potential is enormous.
Okay, physical, psychosocial, privacy. What were the others?
Fourth, ethical and bias risks. The AI learns from data, often human data. What if it learns and replicates harmful biases in its interactions or decision-making? Fifth, the economic impact. We talked about shortages now, but what about large-scale labor displacement down the line? And sixth, the one you mentioned, regulatory gaps.
And that gap seems huge. No specific safety rules for autonomous mobile humanoids?
Pretty much. Existing OSHA standards in the US, or ISO standards globally, they were written for stationary or caged robots, or maybe simple autonomous mobile carts. They don't really address the unique risks of a dynamic bipedal machine interacting closely with people in unstructured spaces. Companies like Figure AI are setting up their own safety centers, which is good, but the official standards bodies have a lot of catching up to do, fast.
Okay, so dexterity and safety are huge. What about just keeping them running, practical stuff?
Battery life is still a major practical bottleneck. Our research pointed out most current models only run for maybe 2 or 3 hours on a charge, unless you have very specific, dedicated charging stations readily available.
Which really undercuts the 24/7 operation argument that makes the economics work.
It does, for now. Until battery energy density improves significantly, or charging infrastructure becomes ubiquitous and seamless, that 2/4/7 productivity dream remains more theoretical than practical in many settings. Continuous operation is hard when your robot needs a couple of hours of downtime every few hours to recharge.
All right, last big area the research flagged was the geopolitical dynamic. This isn't just a tech race, it's a global competition with different strategies emerging.
Yeah, this is fascinating. You can basically see two competing models for how to win this market.
Model 1?
Model 1 is Tesla. It's the closed ecosystem. Vertically integrated, US-based, betting purely on their own engineering and manufacturing prowess to build an insurmountable cost advantage. They control the hardware, the software, the data, everything. Think Apple's iOS model, but for robots.
Okay, the walled garden approach. What's the alternative?
The alternative is perhaps best represented by companies like RealMan in China, backed by a broader national strategy. It's the open platform model. Think Android.
How does that work for robots?
Their strategy, exemplified by the real-bodied open platform, seems focused on accelerating collective innovation. They're gathering massive data sets from real-world scenarios, that million-sample teleoperation project we mentioned, and making their architecture compatible with industry standards like Nvidia's Jetson platform. The goal appears to be creating a large, open ecosystem where many companies can build upon a common foundation, pooling data and speeding up AI training across the board.
So closed and optimized versus open and accelerated.
Exactly. And our research team noted a potential strategic vulnerability here. While the U.S. often leads in foundational AI research, the analysis suggests there's currently no coherent national robotics strategy in the U.S. that compares to the coordinated state-backed push seen in places like China.
China's treating it as a national priority.
It certainly looks that way, with major government-supported initiatives and summits aimed at building a dominant domestic ecosystem for embodied AI. So the race isn't just company versus company. It's potentially ecosystem versus ecosystem, strategy versus strategy.
Before we wrap up, there was one more interesting point from the research, kind of a curveball from non-humanoid robotics.
Yeah, the soft robotics angle. Research on a drone called the Flexiquad. It's a quadrador, but made of soft, compliant materials.
What can it do?
It could literally compress itself to squeeze through narrow gaps, survive falls from significant heights by absorbing the impact, and then just reshape itself and fly away immediately. No damage.
And the relevance to humanoids.
It highlights a fundamental weakness of the current, very rigid humanoid designs like Optimus or Figaro 2. For them, a fall isn't just inconvenient, it's potentially catastrophic. Broken actuators, damaged sensors, thousands of dollars in repairs, significant downtime. It totally kills the 247 uptime promise.
So the lesson is, maybe rigidity isn't always the answer.
It's exactly. True robustness, especially in unpredictable human environments, might actually come from compliance, flexibility, resilience, borrowing ideas from biology and soft robotics. The ultimate winning humanoid might need to be less like a Terminator and more like, well, something softer. That ability to absorb shocks and keep going might be crucial for surviving the real world outside the lab or structured factory. Hashtag tag tag outro.
Wow. Okay, so this week has really felt like a major acceleration point. The robotics revolution isn't just coming, it feels like it's kicking into high gear.
Yeah.
Let's try to quickly recap the big movements we saw.
Yeah, 4 key things stood out. First, the clear commitment to mass producing the shell, driving that cost down towards the $20,000 mark. Tesla, XPeng, others are all racing there. That makes the economics unavoidable.
Second, the revolution in the ghost. That shift to modular layered AI architectures, the Maestro Strategist writing code, the BFM-Zero cerebellum handling movement, that's unlocking more complex, adaptable behavior.
Third, real-world deployment is happening now, not just demos. Figure BMW, Schaeffler committing to 100 plants with Digit. The pilots are turning into actual industrial rollouts.
And fourth, the big challenges are coming into sharp focus. Nailing dexterity with touch feedback, sorting out the urgent safety standards, and navigating this complex geopolitical race between closed and open platforms.
And the conclusion from our research team seems pretty clear. The long-term winner in this market probably needs to nail all 3. They need the cheap hardware, that Tesla-level manufacturing scale. They need the smart, flexible AI, that Maestro-level orchestration. And crucially, they probably need that physical resilience, learning from soft robotics to make machines that don't shatter when they inevitably stumble.
So the final thought we want to leave you with today is this. The rise of the machines isn't really an if question anymore. It's a frantic global race, figuring out the how many, how fast, and maybe most importantly, under what rules.
And this transition, it's going to force all of us as a society to really grapple with what work even means when a $20,000 machine can potentially do many human tasks 24 hours a day.
Right.
What happens to the value of labor when the cost of capital drops that dramatically?
The Industrial Revolution took generations. The digital one took decades. This embodied AI revolution, it feels like it's unfolding in mere years.
It's moving incredibly fast.
Absolutely. Well, if you found this discussion insightful and want to keep up with these rapid changes, please, if you're on YouTube, take a moment to like this video, subscribe to Tomorrow Unveiled, and hey, maybe hit that new hype button. It apparently helps more people find the channel. And definitely turn on notifications so you don't miss our next deep dive.
And if you're listening on a podcast service like Apple Podcasts or Spotify, leaving a rating and a quick review for Tomorrow Unveiled would be amazing. It genuinely makes a huge difference in helping new listeners discover the show.
Thanks so much for tuning in. We'll be back next week, continuing to unpack the future as it unfolds right here on Tomorrow Unveiled.